Okay, so today and the next lesson as well, tomorrow, we will be looking at trigonomic graphs. So we're going to look at some graphing these next 2 days. All right, so first of all, the formula that we're going to be referring to is on your formula sheet. It's y equals a sine b x minus c plus d. And then it's the same for the cosine. All right, and some words we're going to be using is, first of all, the a, you probably, from our transformations unit, you would refer to a vertical stretch. In trigonometry, it's still a vertical stretch, but we also have another word we're going to be using called amplitude, and we will talk about what amplitude means in a little bit here. Okay, the b value you would be using as a horizontal stretch. It's still a horizontal stretch from transformations, but also the b value can help us find the period using this formula. So it's not the period, it helps us find the period of a graph using period equals 2 pi over b. Okay, and we'll also talk about what we mean by period of a graph. C still shifts our graph left or right, and we'll be getting into this a little more in tomorrow's lesson. And the D still shifts our graph up or down, but another word that we'll be using for our D value is midline. So midline or median actually, so two words. Midline, median. So in today's lesson and tomorrow's lesson, we'll just be throwing a little more vocabulary at you. Okay, so with our trig graphs, these are the three primary trig functions which we will be discussing. We'll be spending most of our time with cosine and sine. So let's just start off by graphing the cosine and sine graph. So go to your graphing calculator. Okay, and we're going to go to radian mode. So go to radian mode if you're not in radian mode. And then we're going to type in cos x. So let's type a cosine graph. So cos x graph, and you're going to get something like this. So it's a wave type graph. Those of you who have taken physics, this may look familiar. We're going to play around with the window because actually our trigonomic graph is related to the unit circle. So the highest it's going to go up is the radius of the unit circle, which is of course 1. So I'm going to make my y max -2. Or my y min -2 and my y max 2 because I know the highest it's going to go up is 2. Now, when you think of your unit circle, okay, what would be one period? So one cycle of the graph would be 2 pi. One cycle of the unit circle is 2 pi, so one cycle of our graph is 2 pi. So we're going to make our x min -2 pi and our x max positive 2 pi. In this way, we should be able to see 2 cycles of our graph. Okay, and then we'll graph it. And there's our graph. So you can kind of see those two different cycles there. It's starting, when you look at the y-axis, it's starting from its maximum point. On the right-hand side of that y-axis, you can see one cycle of the graph. The highest it goes to is 1, and that's because the radius of the unit circle is 1. Okay, so it's going to be consistent when we graph that trigonomic function. Okay, so this is our cosine graph. While we're with our graphing calculator, while we're using it, let's go ahead and see how the sine graph is different. Okay, so for the sine graph, it looks exactly the same. Okay, I still see one cycle of the graph on both sides of that y-axis. The maximum point of the graph is still 1, the minimum point is still -1. However, the difference is that it starts at a different place. So on the y-axis, you can see it's kind of starting in the middle there rather than the top, the maximum point, such as the cosine graph. And that is going to be important in tomorrow's lesson. We won't get into horizontal shift too much today. And then of course, let's try graphing tan as well. Okay, so our tan graph looks pretty crazy. On some graphing calculators, you may see it, but the tan graph actually has asymptotes. The reason for that is, if you remember, tan is equivalent to sine over cosine. So whenever cosine is 0, you're going to have an asymptote on your graph because we can't have 0 as a denominator. So when you go back to your unit circle, cosine is equal to 0 at 0 or 90 degrees, yeah, and 270. So if you were to look at your asymptotes, they should be at 90 degrees or pi over 2, and 270, which would be 3 pi over 2. Okay, so let's go back to our PowerPoint here and talk about some of these new words. Okay, so amplitude, I'm going to draw on my picture here. Amplitude is a distance, so it's always going to be a positive number. If you were to take your graph and draw a line on the midline, which is the middle, hence why it's called the midline, your amplitude would be the distance from that midline to the maximum point, okay, which should be the same distance from the midline to the minimum point. The reason being is because our graph is symmetrical in nature. Another formula you can use, this is not on your formula sheet, okay, but it can be helpful with some questions, is amplitude is equal to the maximum point on the graph minus the minimum divided by 2. And when you're using these formulas, you'll always be using the y values when you're plugging those numbers into the formula. Okay, so period of our graph. The period is one cycle of the graph. So you can actually start anywhere on the graph. I generally like to start on the y-axis just because it's a little easier to figure out the period. Okay, and then you want to figure out when it starts repeating. So this blue line, that represents one full cycle of the graph. If you were to look further than the blue line, you would notice that the graph is repeating. So it just keeps going in a cycle, in a wave-like motion. Okay, the b value, you'll see absolute values. You always use a positive b because, once again, period represents kind of a distance on the x-axis this time. So you're not going to have a negative period on any of your graphs. So you'll always use a positive. Okay, so let's actually look at some examples. So I like to, and this is just a preference, I like to draw my midline. So I'm going to go ahead and draw that midline. So this one's easy. The midline's just at 0, okay, where y is 0. All right, and my amplitude would be the distance from the midline to the maximum point. So it's 10. So my amplitude is 10. Super easy to double check. Is it the exact same to the minimum point? Yes, it should still be 10. Okay, the period of the graph, again, I'm looking for one full cycle. So I'm going to look at the x-axis on the period of my graph. So I'll start the y-axis, y-intercept there, okay, and then draw to where it starts repeating. And at 8 is where that graph starts to repeat, which means the period of my graph is 8. Okay, let's do the next one. So again, I like to always draw my midline. That's just my preference. This one's again easy because the midline's just on the x-axis. That won't always be the case though. Okay, and if I draw my amplitude, I see that it's 2, right? Because that's the distance from the midline to the maximum point, or from the midline to the minimum point. So amplitude is 2. I also just want to show you how this formula works. Amplitude equals max minus min divided by 2. Okay, so if you wanted to use the formula, you would take the maximum, which is 2, minus your minimum, which is negative 2, all over 2. So of course, 2 minus negative 2 is positive 4, divided by 2 would also give us 2. Okay, and then the period of the graph, if I draw it on my graph here, I'm going to start on the y-axis, and then draw 2 on the x-axis where it starts to repeat. So it's going all the way over here, which is 2 pi. So the period of this graph is 2 pi. Okay, so this just kind of repeats what we already talked about. Instead of period equaling 2 pi over b, if you're dealing with a graph in degrees, you'll see 360 degrees over b. Generally, most of the graphs we will be looking at will be in radians, not degrees. So if you were graphing and you were in degrees, instead of going to 2 pi, you would set your x max and x min to 360 or negative 360. Okay, so we don't really look too much into tan. The only thing that you will probably notice with tan is tan will have a different period. So when we graph tan, and I guess I could have pointed this out, so you could try graphing it again. Okay, you would have noticed, this is kind of what the tan graph looks like. I'm not doing a great job of drawing it, but there was actually, instead of 2 cycles, there was 4 cycles of the graph that was shown between negative 2 pi and positive 2 pi. The reason being is because tan has a period of pi over b, while the period of sine and cosine is 2 pi over b. Okay, so that's the one thing you need to pay attention to with tan. You won't get too many questions about tan graph, but that will come up. Okay, so now let's use the equation, and I'm going to write it out here. Again, this is on your formula sheet. Okay, so let's see if we can find the amplitude, period, and equation of the midline. So we're going to introduce the midline as well. So my first example here, my amplitude is 6. Okay, my b value, because there's no coefficient here, I would assume the b value is 1, which means my period would be 2 pi over 1, which is just 2 pi. Right, and of course we're using that equation that was on the first screen there, period equals 2 pi over b. The midline, okay, is that d value. So that is your midline. So in this case, my midline would be 2. It's always the constant. All right, so 2 is my constant, so I need an equation of the midline. So I would just say y equals 2. Okay, now for my next question here, just like we're kind of used to here, when you're ever looking at graphs, you do want to, and you have a b value, you want to factor that b value out. So it's going to look like this. So my amplitude, because there's no leading coefficient, there's no a value, I'll assume it's a 1. My period would be 2 pi over my b value, which in this case is 4. 2 pi over 4 will of course reduce to pi over 2. And then I actually don't have a midline, right? That 2 would not be a midline. That's our horizontal shift left or right because it's our c value. So because there's no d value, we would just assume the d value is 0, right? It's the same as adding 0. So my midline would be y equals 0. Okay, and we're going to skip this one. You can try it if you want. The answers are in the notes online, and we'll move ahead. All right, so let's look at a couple of examples here. So consider the partial graph, state the amplitude and period. So this graph's pretty nice because the midline's right in the middle there. Okay, so the amplitude would be the distance from the midline, okay, to the maximum. And it should be the same distance from the midline to the minimum. So I know my amplitude right away is 3. Okay, so my period, I'm going to draw this out here. I'll use a different color. I'm going to start at the y-axis and draw till I see the graph starting to repeat. So it's repeating right here. Okay. Also, when you're looking at graphs, you want to pay attention to the increments of the dashes on the x-axis and y-axis. So when you look here, this little dash here is pi over 2. So if I'm adding pi over 2 each time, I know that my period is actually pi. Right? Because pi over 2 plus pi over 2 is pi. So my period of my graph is pi. It says determine the equation of the sine function. So we need to see if we can fill this in now. Okay, so I know my amplitude is 3, so my a value is 3. My b value, because my period is pi, we can use that equation. So period equals 2 pi over b, which means b equals 2 pi over the period. So the period is pi. So b equals 2 pi over pi, which is just 2. So I know my b value is 2. There is no c value. Again, we'll talk about this a little later. The reason being is the graph was not shifted left or right. We know this because it starts at the midline, right? And if you were to compare it to that original sine graph, we know that it should start at the midline, right? If it didn't start it on the midline, it would move left or right. But don't worry, that's probably the hardest part of the concept. We will talk about that tomorrow. All right, so I just have 2x, and then my midline is 0, so I don't even need to write that in. So the beautiful thing to double check and make sure you're right, just graph this. Does it give you the same picture? If it does, you know you did it right. All right, let's try the next one. So again, I like to start by drawing my midline. This one again is super easy because the midline's at 0. Okay, my maximum or my amplitude is from the midline to the max or from the midline to the min. So I know my amplitude in this question is 4. My period, I'm going to start here. I see that it starts at the maximum and goes all the way here. Okay, so this would be 1 period of the graph because then at this point it starts to repeat. So I have to figure out what are the increments on that x-axis. So it looks like it's going up by 3s. Okay, so that means the period of the graph is 12. All right, 3, 6, 9, 12. So that has to be 12. Okay, so now we can fill in our equation. Y equals a, this time we're doing a cosine graph, cos bt. A equals, and I guess I should have said a instead of y. Whoops. 4 cos. B value, again, the b value is not 12, the period is 12. So to find the b value, period equals 2 pi over b, which means b equals 2 pi over period. I know the period of this graph is 12, so I'd have 2 pi over 12, which reduces to pi over 6. So my b value is pi over 6. Okay, and you know that's your formula. And again, you can try typing it in your calculator to make sure you did it right. So tomorrow we'll be looking a little more at that horizontal shift as well as the vertical shift, also called your midline. You can try some of the questions in here and let me know if you need any help.